Hello students, this is Ashwini working as Assistant Professor in the Department of Civil Engineering, PES College, Mandya. In this session, let us conduct the experiment on impact test on mild steel. So what do you mean by impact load? The sudden load acting on any member is defined as impact load. The impact test determines the amount of energy absorbed by a material during fracture. This absorbed energy is a measure of a given material's toughness and acts as a tool to study temperature dependent brittle ductile tension. In this session, let us conduct the experiment on impact test on mild steel. So what do you mean by impact load? The sudden load acting on any member is defined as impact load. The impact test determines the amount of energy absorbed by a material during fracture. This absorbed energy is a measure of a given material's toughness and acts as a tool to study temperature dependent brittle ductile transition. It is to determine whether the material is brittle or ductile in nature. So here we have two experiments. One is Izod impact test and Charpy impact test. The first experiment is Izod impact test. The aim of the experiment is to determine impact value, that is Izod impact value and Izod strength of a given specimen. And the operators required to conduct the experiment are impact testing mission, specimen, that is here we use mild steel, and scale. This is the Izod specimen where a notch is made at a distance of 1/3 from the top or 2/3 from the bottom, and this is impact testing mission where this is called as pendulum, this is scale, this is mission framework, and this is the test specimen, this is support, and this is foundation. Why do we use notch in the impact test? Impact energy is a measure of the work done to fracture a test specimen. When the striker impacts the specimen will absorb energy until it yields. The test specimen continues to absorb energy and work hardens at the plastic zone at the V notch. So when coming to the procedure, first we have to measure the dimension of the given specimen at V notch and we have to calculate the area under V notch. Then set the dial pointer to a maximum load. Here in Izod test, we fix the maximum load to 17 kg force meter. So after that, raise the pendulum to a certain height so that the pendulum fixes automatically to a level of 17 kg force meter. After, release the pendulum to fracture the specimen fixed like a cantilever with its face having V notch in the direction of the striking. Then note down the Izod impact value of the specimen by observing the dial reading which gives the Izod impact value directly. Then repeat the experiment for 2 to 3 specimen and calculate the average impact strength. This is the observation and calculation part. First, you have to note down what is the length of the specimen in millimeters, then what is the breadth of the specimen in millimeters and depth of the specimen below the V notch, and hence calculate what is the area of the specimen below the V notch in terms of millimeter square. So after observing, we have to tabulate the result. So here we are using the mild steel specimen. So area we have calculated, that is area of the specimen below the V notch, mention the values of the area below the V notch and observe the dial gauge reading from the impact testing mission and note down the energy in terms of kg force meter directly. Then Izod impact strength is determined by using the equation E by A, that is energy absorbed divided by area under the V naught. We will get Izod impact strength in terms of kg force meter per millimeter square. Then take the average of the values, that is average Izod impact value in terms of kg force meter, then average Izod impact strength in terms of kg force meter per millimeter square. Then tabulate the result, that is average Izod impact value in terms of kg force meter, then average impact strength in kg force meter per millimeter square. Now let us conduct the experiment. This is impact testing mission, where we conduct both Charpy and Izod impact test. Izod testing specimen, where a V-notch groove is made at a distance of 1/3 from the top or 2/3 from the bottom. This is observation and tabular column for Izod impact test. Now let us take the measurements. First, let us note down what is the length of the specimen. Here length of the specimen is 81 mm. Breadth of the specimen is 9 mm. Depth of the specimen below the V notch is 8 mm. Enter all the values in observation sheet, that is length of the specimen is 81 mm, breadth of the specimen is 9 mm, depth of the specimen below the V notch is 8 mm, and hence calculate area of the specimen below the V notch. Here we have to consider breadth into depth in order to calculate area of the specimen below the V notch. That's why it is 9 into 8, which is nothing but 72 mm square. For Izod test, move the lever arm towards Izod. Set the pointer to a maximum load of 17 kg force meter. Here, least count of the dial gauge is 0.2 kg force meter per division. For Izod test, striking edge must be flat. Fix the striker to the pendulum. Fix the Izod specimen in between the jaws in cantilever position such that V naught should be towards striking direction. Raise the pendulum to 17 kg force meter. Now release the load. There are two scales here. One is inner scale and another one is outer scale. Inner scale is used for Izod test and outer scale is used for Charpy test, where the least count for both the scales are 0.2 kg force meter. Now here in this experiment, the energy absorbed is 10.4 kg force meter for Izod test. Note down the energy absorbed to fracture the specimen. Calculate Izod impact strength, that is by using the formula E by A, where area is 72 mm square. Here we got Izod impact strength as 0.144. Similarly, repeat the experiment and note down the values, and hence calculate Izod impact strength. And hence calculate average Izod impact value in kg force meter and average Izod impact strength in kg force meter per millimeter square, and tabulate the results.